Hi, I'm Kathy Stark. In this lesson, we introduce the concept of probability, go over Venn diagrams, look at a formula for calculating odds, as well as a binomial probability formula. The first thing you need to understand is that probability operates on experiments. It's a good idea to be able to write a sample space, which is a list of possible outcomes for an experiment. Let's give that a try. What we want to do is write a sample space for the experiment in which 3 ordinary coins are tossed. Let's let the letter H represent the fact that we get heads when we toss the coin, and T, tails. Now we're going to toss 3 coins, so it's possible that they all end up as heads. It's possible that the first is heads, the second is heads, the next tails, or we might have heads, tails, heads, or we might have tails, heads, heads. Continuing, it's possible that the first is heads, the seconds are tails, or we might have something like tails, heads, tails, or tails, tails, heads, and finally, tails, tails, tails. These are all the different possibilities that could occur if we toss 3 ordinary coins. This is the sample space for the given experiment. Now, probability operates on sample spaces in this way. In a sample space with equally likely outcomes, the probability of an event E, written P of E, is the ratio of the number of outcomes in the sample space S that belong to event E, that's written N of E, number of things in E, to the total number of outcomes in the sample space S, written N of S. That is, probability of E is the number of things in E divided by the number of things in S. We need to work an example of this. An unprepared student takes a 3-question true-false quiz in which he guesses the answers to all 3 questions. Write each event below in set notation and give the probability of that event. First of all, the student gets all 3 answers correct. Secondly, he gets all 3 answers wrong. Third, he gets exactly 2 answers correct. And fourth, he gets at least 1 answer correct. I think it'll help in this problem if we write down the sample space. I'm going to use W for a wrong answer and C for a correct answer. Now there's 3 questions on the quiz, so it's possible that the student guessed correct, 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 or correct, correct, wrong, or correct, wrong, correct, or wrong, correct, correct. Continuing, it could be correct, wrong, wrong, or wrong, correct, wrong, or wrong, wrong, correct, and finally, I'll write the final result here, wrong, wrong, wrong. Here's our sample space. We can use the sample space to answer the questions. We want to write down the event that he gets all 3 correct. We can write it as I have already. Here's our event. To figure out the probability of our event, we want the number of things in that event divided by the number of items in the sample space. The number of things in that event is 1, and there's only 1 option there. The number of things in the sample space, 1, 2, 3, 4, 5, 6, 7, 8. That's the probability that he guesses all 3 correct. Well, all 3 wrong. That event is as listed, all 3 wrong. And the probability, again, is the number of things in that event, 1, divided by the number of things in the sample space. Let's move on to part C. I've rewritten the sample space here. I want to know the probability that the student guesses exactly 2 correct. Again, that's our event, exactly 2 correct. Now the probability of that is the number of things in that event divided by the number of items in the sample space. Well, there's 1, 2, 3 options in which he guesses 2 correct, and 8. in the sample space. For him to guess at least one problem correct, we can do a number of things. Let's just count in our sample space. So E is at least one correct. The probability of that event is here's at least one correct. 2, 3, 4, 5, 6, 7 out of the 8 options give at least one correct guess. We move on from here to another concept involving probability, the idea of the complement of an event. The complement of event E, written E prime, is the set of all outcomes in a sample space that do not belong in that event. Think of the event from the experiment drawing a card out of a deck of 52. Suppose that our event is that you draw the king of clubs. Then the complement of that event would be that you do not draw the king of clubs if you draw one card out of the deck. There's a couple other items to notice about an event and its complement. The union of the event and its complement is the whole sample space. The intersection is the empty set. They cannot both occur at the same time. Well, we have something called a Venn diagram that illustrates this idea of an event and its complement. Here's a general Venn diagram. The rectangle represents the overall experiment, and within the rectangle, in a circle or circles, we put all the items in a particular event. Outside the circle but inside the rectangle are all the items that would be in the complement of that event. Let's look at an experiment and use a Venn diagram. A marble is drawn at random from a box containing 3 yellow and 4 white, as well as 8 blue marbles. Find the probability a yellow marble is drawn. We're going to draw one marble. We have 3 yellow, 4 white, and 8 blue. If we let E be the event that a yellow marble is drawn, a possible Venn diagram for this, where the box represents the experiment, is to put the event E inside. Now there are 3 yellow marbles in our box. Outside, but inside the rectangle, outside the circle, inside the rectangle, I put the number 12, all the remaining marbles together. Now if I want the probability of the event we draw a yellow marble to occur, that's 3 divided by 15, all the other marbles in the box. That reduces to 1/5. Let's move on from here to define odds, and then we'll come back to this experiment. The odds in favor of an event E are P of E divided by P of E prime, its complement. If this ratio is m to n, then the probability of E is m over m plus n, and the probability of E prime is n over n plus m. Let's use that with the same experiment. So we have a marble drawn at random from a box containing 3 yellow, 4 white, and 8 blue marbles. But this time we want to find the odds in favor of drawing a yellow marble. Odds in favor this time. Now the probability of drawing a yellow marble we calculated as 1/5. The complement of the event drawing a yellow marble is the event that we do not draw a yellow marble. And in our box, we had 3 yellow, 4 white, and 8 blue. There are 12 marbles that are not yellow, so the probability of the complement is 12 out of the 15 marbles, which reduces to 4/5. But we want the odds, not the probability of the complement. The odds are defined to be the probability of an event divided by the probability of its complement. In this case, 1/5 divided by 4/5 which is 1/5 times the reciprocal 5/4, the fraction 1/4. Generally, that's written 1/4. That's the odds of drawing a yellow marble. Well, we move on from here to look at two events and the probability of one event or the other event occurring. Here's a formula. If we have two events, E as well as F, for an experiment, the probability of E or F occurring is the union symbol. That's the probability of E union F, which is calculated by finding the probability of E, adding the probability of F, and subtracting the probability of E and F occurring. Let's work on the same experiment, but try a different problem. A marble is drawn at random from a box containing 3 yellow, 4 white, and 8 blue. Find the probability the marble is yellow or white. Let's see how this works. I want to let E be the event that I draw a yellow marble, and F that I draw a white marble. I'm going to begin by drawing a Venn diagram that will represent this problem. I have two events that do not overlap, event E and F. Let's get the numbers that correspond to those. There are 3 yellow marbles and 4 white marbles, 8 blue in between. Now what I want to do is find the probability of E or F, the probability I draw a yellow or a white marble. According to the formula, another way to write this is E union F. I find the probability of E plus the probability of F minus the probability of E intersect F. Now the probability of E is 3 out of 15, 3 out of the total. The probability of F is 4 out of the total. There is no overlap. There is no marble that is both yellow as well as white, so I don't need to subtract anything. This sum is 7/15. The probability of drawing a yellow or a white marble is 7/15. Well, I'd like for you to give this a try. Here's an example. Mrs. Schmulin invites 10 relatives to a party. Her mother, 2 uncles, 3 brothers, and 4 cousins. If the chances of any one guest arriving first are equally likely, find the following probabilities. The first guest is an uncle or a brother. The first guest is a brother or a cousin. The first guest is a brother or her mother. Stop the tape, and when you're ready, restart the tape to check your work. Let's see how you did. We have 10 relatives invited, a mother, 2 uncles, 3 brothers, 4 cousins. We want the probability that an uncle or a brother arrives first. Let's calculate that, considering the uncle arriving first to be E, the brother to be F. The probability of E or F is the probability of E, I'll write it once for you, plus the probability of F minus the probability of E intersect F. In this case, the probability that an uncle arrives first is 2 out of the 10 relatives. The probability that a brother arrives first is 3 out of the 10, and there is no relative that fits into both of those categories. This sum is 5/10, which is 1/2. Now what about a brother or a cousin? Again, we can choose E for one of these and F for the other. The probability of E or F, as you can see from the formula, is the probability that a brother arrives first, 3 out of 10, plus the probability that a cousin arrives. Now there are 4 cousins out of the 10 relatives, minus the intersection of those. This sum is 7/10. Let's continue to do the third part of the problem, which is the probability that a brother, we'll let that be E, or her mother arrives first. That's the probability of E or F. The probability that a brother arrives first, there are 3 out of the 10, plus the probability her mother, well, there's only one of those, minus the intersection. The sum is 4/10, which is 2/5. Now, there's some probability properties I'd like to review for you. We've used them, but now it's time to write them down. For events E and F, a probability has to be greater than or equal to 0, but less than or equal to 1. The probability of a certain event, an event that will occur, is exactly 1. The probability of an impossible event, one that will not occur, is exactly 0. The probability of E complement, this should be complement, is 1 minus the probability of E occurring. And the probability of the union of two events, remember that this can be considered the word or, is the probability of E plus the probability of F minus the probability of the intersection. We're going to move on from here to look at a specific formula for probability called binomial probability. A little bit of an introduction to that. If an experiment consists of independent trials with only 2 outcomes on each trial, so there's only 2 possibilities that can occur, then we call it a binomial probability formula. Here's the formula to calculate that. Let the probability of success in one trial be P. The probability of failure is 1 minus that, like the complement formula. And the probability of R successes in N trials, remember there's only 2 possibilities in each trial, is given by this. This says N choose R, which is our combination formula, times P to the R power, times 1 minus P to the N minus R power. P is the probability of success in any trial. Let's use this now. A die is rolled 12 times. Find the probability of rolling no more than 3 ones. In order for this to be a binomial probability problem, we need to figure out what the 2 possible outcomes for the experiment are. Our successful outcome is rolling a 1 on the die. Our failure outcome is not rolling a 1 on the die. We're going to run the experiment 12 times. We want the probability of rolling no more than 3 ones. Let's get started. We're going to run our experiment 12 times. Now the probability formula for binomial probability is N choose R, P to the R, times 1 minus P to the N minus R. P is our successful outcome, and that's the probability of rolling a 1 on one roll of a die. 1 minus P is the probability of not rolling a 1. The value of P then is 1 out of 6. 1 minus P is anything else other than a 1 when you roll a die. 5 out of 6. N is 12. We're running our experiment 12 times, but we want the probability of rolling, notice what it says, no more than 3 ones. So 0 ones is okay, 1 is okay, 2 is okay, 3 is okay. There's 3 different values for R. If I write the formula down 4 times, what I need is 12 choose 0 times 1/6 to the R power, which is 0, times 5/6 to the N minus R, 12 minus 0. And I need that plus 12 choose 1, 1/6 to the 1, 5/6 to the 11th, which is 12 minus 1, plus 12 choose 2 times 1/6 squared times 5/6 to the 12 minus 2 is 10. And finally, I need to add 12 choose 3 times 1/6 to the 3rd times 5/6 to the 12 minus 3, which is 9. That's a lot of calculations on your calculator. I'm going to go ahead and write down the answer and then show you a really neat way to calculate this on your calculator. The final result will be 0.875. Well, let me show you how we can use a graphing calculator to help with this one. Here's what we're going to do. Go into y equals, and as y1, we'll put the formula, but instead of putting in an r, we'll put the variable x. So parentheses 12. Now n choose r is the same as combinations. So go to math, go to probability, option 3. Next to that, I'm going to put an x, which is sitting where my r in the binomial formula would be. I have that times 1 divided by 6 to the x power. And that is times 5 divided by 6 to the, in parentheses, 12 minus x power. So my formula's in, and I need to find the value of this for the x numbers 0, 1, 2, 3. I'm going to get them off my table. I'm going to set my delta table to 1, and I'm going to start the table at 0. Now I want to do auto, not ask. Let's look at the table. The table gives lots more information than I needed. What I need are the first 4 numbers, 0.1121, 6, 0.26918. This is r equal to 0, r equal to 1, r equal to 2, r equal to 3. What I need to do is take those 4 numbers, add them together to get the result. Let me do that on a piece of paper. Take those 4 numbers, and here they are. I have the number 0.11216 plus 0.26918 plus 0.29609 plus 0.1974. You'll find if you add those together, we get exactly 0.875, and this is the probability of rolling no more than 3 ones. In conclusion, we looked at probability and worked with the binomial probability formula. You need to practice by doing lots of problems from your textbook.